Hi guys, welcome to the Fried Circuit, the CAJCS Full Steam Ahead podcast, hosted by Ved Prasad.
And Saksham Sood.
Here we discuss everything related to science, technology, engineering, art, and math. So if there's some topic that's related to one of those, we're definitely discussing it here.
Yeah, a bit of background about CAJCS Full Steam Ahead. We're a completely student-run organization in the Cathedral and John Connon School, Mumbai. We basically do projects, host competitions, and create content regarding STEAM, which, like Wade said, is science, technology, engineering, art, and mathematics. You can check us out at cathedralfsa.com, and we have a coding competition called CathCon coming up from 6th to 8th August. So you can also go and register for that if you're into coding. Now, we've been gone for a week. Uh, and
Yeah, we've had some
the
stuff
reason
going
for
on.
that is we have some stuff going on.
Yeah.
We had dramatics, which was an in-school event. I fell sick for a bit. But the most exciting one is that we have been planning a special episode for the last 3 weeks almost. We've been in conversation trying to find
Right. Yeah.
trying to organize this and make sure it happens in the best way possible.
Yeah.
And we now that it's finalized, we're here to announce it. We are doing a special live episode of the Fried Circuit on 6th August at 4 p.m. IST on this YouTube channel. Okay, so if you
Right.
tune in, you're going to see a very special episode we guys have planned with a very special guest, uh, who
Mr.
is
Ravneet
Mr.
Singh
Ravneet.
Fokela. Right.
Exactly,
So
yes.
he's actually the chief business officer at Aether Energy, and Aether Energy is basically an Indian company that specializes in making electric scooters, and they're really changing the landscape of electric technology right now, electric vehicular technology right now. Some would say they're the Indian version of Tesla.
Mhm.
So make sure you tune in. It's
Yeah,
again
I would
Friday.
say similar-ish, definitely.
Yeah,
Yeah.
again, yeah. Friday, 4 p.m. Indian Standard Time. It's 6th of August. Tune in, and it's going to
Yep.
be streamed live here on the Fried Circuit on the Cathedral and John Connor School Full Steam Head YouTube channel. So make sure you subscribe so you don't miss it.
Yeah, turn on the notification bell as well, so you get like a little notification in your email
Yeah,
when we're live. A very interesting
yeah,
thing is we're also gonna have a live chat during the live stream, and if you have any questions regarding anything that we're talking about, you can ask a question in the chat, and in the end, we'll have a small Q&A session. Basically, we'll take
right,
questions from you guys and ask him directly.
yeah,
Okay, so definitely research, read up on it. You can also watch our episode on cars. We talk about electric vehicles for a long amount of time,
yeah,
and you
yeah.
can
It's
get
a great way
started
to
on
prepare.
everything.
Right,
Yeah, definitely check out Ether Energy as well. To be better prepared for the episode, basically we'll be talking to him and basically an industry specialist about stuff
yeah,
that we've covered before, right? EVs and electric charging and the electric vehicle industry in general, especially in India, where we recently seen that EVs are growing in popularity and people are actually taking them seriously, which is a good
right.
thing. Yeah. Uh,
But now,
On to the episode now.
right,
So, today's topic is artificial intelligence, which I'm 100% sure whoever you are watching right now, you definitely heard of AI. It's the internet's favorite buzzword for anything to do
yeah,
with computers.
just artificial intelligence and machine learning, two terms that just keep floating around, two terms that people are just constantly mentioning.
Yeah, if you see an
Lucky for
ad
you
about
though,
anything
if
to
you
do with
don't,
a company or a
yeah,
software, anything, it's
yeah,
most likely AI powered or
yeah, yeah,
machine learning algorithms.
driven by machine learning and deep learning. But if you're
Yeah,
someone who keeps seeing these buzzwords up on the internet, people keep talking about it, and you don't know anything about it, so you feel kind of left out, don't worry, the Fried Circuit's got you.
we've
Because
got you
today
covered
we're going to discuss like enough and more to basically make you
about
an expert in the
artificial
field of
intelligence.
AI.
Yeah,
Yeah,
basically, we're helping you guys avoid scams by explaining to you what AI means. Because half
we
of the
really
times you
are.
see the word AI, it has
Yeah,
nothing to do with the context it's being used in, right?
right.
In fact, we, despite being computer kids and researching the episode, found out a lot more about AI, and like it really changed our perspective on what AI can do and what it actually
Yeah,
is.
there's so much stuff we
Uh,
didn't know earlier, but now we do, and we're sharing it with you guys.
Exactly. Yeah.
So,
I mean,
yeah,
on first glance, AI might feel like this super complicated thing that only is
yeah,
used in like these big servers in these multi-billion-dollar companies, etc., etc. Which is true. Yes, it is.
it is.
But
It
I'm
is.
also very, very sure that you have definitely encountered AI somewhere in your life.
Yeah, you
AI
personally
is used.
have used a product that is powered by AI. It was used in very simple
It's
places and
actually
places that
powered by
most,
AI.
yeah, yeah, actually. because it's you find it in very simple places and places that any like internet user will come across multiple times during their lifetime.
Exactly.
Places like
Mm-hmm.
popular platforms actually like social media platforms like YouTube,
Instagram,
TikTok,
TikTok.
Instagram, all of them, Twitter, all of
In
them
fact, if you're
have
watching this episode, it's probably on YouTube, which means you have
yeah,
encountered AI just by clicking over here.
right,
Uh,
right,
it's all powered essentially by AI. And I think we're going to get into this in a bit as well. There are certain AI applications or certain AI implementations that were considered AI back when they were invented, but have over time become so commonplace in technology around us that they aren't even considered to be intelligent anymore. They're
right,
just considered a
yeah,
normal part of functioning. Stuff
exactly,
like Siri, for example. Oh, no, it's not Siri, sorry. Siri's still considered AI, but stuff like voice recognition, right? Like when
yeah,
you're talking to your car, let's say, or you're giving instructions to a robot or something, or like a Roomba around your house or something.
right,
Stuff like that used to be super high tech can now be found in stuff like children's toys, where you can tell your toy, car move forward and the car goes forward. That isn't considered AI anymore.
right. It
But it
used to be
used to back
considered
then.
like a huge breakthrough in the field of artificial intelligence, right? This huge new feature
Mm-hmm.
that can be implemented anywhere. Like your machine can actually understand things that you tell it verbally instead of communicating through a keyboard or through some
Mm-hmm.
sort of control panel. But like Saksham said, now you find it in the most simple places. Like you can buy a toy car, you can buy a toy car which is powered by some sort of chip, right? Maybe an Arduino, any form of like a
Yeah.
computational chip, and you can just speak to it, and it'll just work. It'll do exactly what you tell it to because these features, which were once really like big and revolutionary, are now so basic and so like uh, common, right? It's so
Yeah. They're
widespread that you
almost
find it in these
fundamental in certain
right, exactly,
applications.
right, and
Yeah.
now you find it in these like basic technologies, and that's how that's the impact that AI has already had on technology as we know it.
Mm-hmm. Exactly. So AI essentially, I don't know if I were to explain AI in a one line simple sentence, it would be a completely different or a shift from the traditional way of programming. Okay, so a shift from traditional functionality of a program, let's say, a way to code it differently in an AI way, would then make it behave differently. That's what AI essentially is. It's coding a program in a different way to make it more intelligent. We're gonna get into what intelligent means again, but before that, let's just talk about traditional programs first. Let's talk about simple
Right.
code that we're all very familiar with, that we would not associate with AI per se.
Let's talk about the technology that functions the basic way, like the traditional way
Mhm.
again, which is where the user tells it exactly what to do. Right? Now that's the thing. AI,
Exactly.
artificial intelligence, can sort of think for itself, right? In some manner, can do
Hence,
things without you
intelligent.
tell it. Yeah, you can do
Yeah.
things without you telling it explicitly what to do. But we have traditionally programmed machines, okay, and these are the machines that we still use, and we still use these technologies all the time. But these are the technologies that people have been using for decades now. And
Mhm.
like I said, right, you tell it exactly what to do, and it'll give you a result based on that. You give it a very specific input, and it won't do anything on its own. It'll just based on your input give you an output, and that's how these machines have worked for a while now, and for longer than you think.
Mhm.
Because I'm here talking about computers, right? And you probably think, okay, computers, people started using them, in the 80s, 90s. It actually goes back way further than that, right? All the way back
Yeah.
to the 1820s, actually, where Charles Babbage, you probably heard of him. People call him the father of computers, right? It's a pretty heavy title
Yeah.
in the world we live in today. Right? All computers have worked.
Mhm.
Charles Babbage actually made something called the Babbage difference engine. Okay, and
Mhm.
it was a machine that basically you could use it to do arithmetic, right? Addition, subtraction,
Yeah,
multiplication, division.
I
It's
think
basically a
no. So we
calculator.
talked about this in the quantum computers episode, our last episode as well. We talked about traditional computers. It's basically a
Yeah,
bunch of transistors. It's basically a bunch of yeses and nos and zeros and ones, where either current is flowing or it's not flowing. And because of that, that's what the Babbage's first computer was essentially. It was a yes no circuit, uh, that would essentially be the first mechanical computer.
right.
Yeah.
Yeah, right.
Uh.
Exactly. Yeah, and then
Mhm.
again, like I said, it was used for basic arithmetic, so you could use it to calculate really big numbers, all that. And this was all the way back in
Mhm.
1820. This was before the World Wars, before the revolt of 1857. It was before a lot of things. Babbage had
Mhm.
created a machine that could perform complicated calculations. Then years later, right, in the 1900s.
Mhm.
Then we actually got the modern computer. Now, modern, yeah, it's old now, but modern in the sense that it was actually like digital to some extent. And like Sachin said,
Yeah,
they
and if you
use
think about the modern
transistors and things.
computer with the
Right.
zeros and ones, right? Even with them, they weren't exactly what we would call intelligent because you still had to tell the computer exactly what you wanted to do step by step. Which is what coding is, right? If you ever encountered a piece
Yeah.
of code or you looked at an algorithm in simple English as well, it's very, very specific step by step by step by step instructions, which together would form, a big complex operation, right? So if I want to, for example, in Java, let's just take Java for example, because we both know Java.
Right.
If I was to add two numbers in Java, I had to instruct the computer to first take for one number, take second number, put them together, and then show third number.
Right.
Right. So it would take four different steps in Java for you to
Right.
be able to add two numbers. Right. And
Right.
even with modern computers, you still have to do that in most programs.
Yeah.
But how modern computers begin? So I think so. Again, a very influential figure, Alan Turing, who has been instrumental in computation just generally as a field. Uh, During World War II, he was the one who actually helped the Allied forces break the Nazi encryption called Enigma, which was considered to be unbreakable. It was just the
Yeah.
ace up Nazi Germany's sleeve, where they couldn't decrypt any of Nazi Germany's radio chatter, any of the communication. But once they were able to crack that, that's what essentially helped the Allies win World War II because of him.
Right.
Um, and he's the
People
one who actually
people
got us started on AI.
yeah. He was very big
Mhm.
in that way because people thought that Enigma would be a large part in Germany winning the war because every single message that Germany communicated to other Germans, no one could
Mhm.
decrypt it. It was extremely advanced. But then Alan Turing
Mhm.
helped the Allied forces decrypt it, and for the latter part of the war, the Allied force was just listening in on everything, right? And he
Yeah.
actually developed some form of the modern
No, actually,
computer to do this.
about Enigma also just one more time.
Yeah,
A
yeah,
fun fact about the encryption service: the way they were actually able to break it was that Nazi Germany, all the messages ended with Heil Hitler, and because of that, they were able to see that every message had the same bit of code at the end. And when they were able to
right,
figure out what it meant and the fact that it mapped to Heil Hitler, they were able to decode the remaining message as well. It was like a big clue that helped break
right,
the Enigma code.
yeah.
Yeah,
And
but back
then
to Alan Turing. Hmm.
yeah, so Alan Turing helped them win the war. Obviously, World War II got over in 1945, and then in 1950, Alan Turing actually published a paper called "Computing Machinery and Intelligence." Okay, it's online. It's a I think
Okay.
22-23 page paper you can read for yourself. And in this paper, he basically proposed. He opens with this question, right? He proposed the question:
Hmm.
Can machines think? So he'd spent so long dealing with computers and like modern computers now,
Hmm.
when it came to the war and helping the Allied forces win. But over there, it was always them plugging in some input, getting its output, right? Traditionally programmed machines. Now, all the way back in 1950, he was thinking, okay, we've gotten to this stage of
Yeah.
computation, right? Where to provide something, get something. What if machines themselves can think and automate these tasks?
Yeah.
And
What if you
in order,
could essentially take what is a very human thing or a very animal thing as well, uh,
yeah,
which is thinking, just naturally thinking for yourself independently about something, and can
right,
we replicate that using a computer?
exactly, right.
Right.
That's what he thought about.
Uh,
And
yeah. And he came up with this thing. He came up with a test essentially for whether machines
yeah,
could think, and he called it the imitation game, which is since been renamed the Turing test after him. Uh, and the way this test works is that you have a room, or actually you have two separate rooms. One of them has a machine, and one of them has a person, a real human being, and the third person. And none of them can see each other. They're all in separate closed rooms, no windows, nothing. The third person has to write down questions and ask those questions to the person and the computer together, which will both
right,
then give a response back to the third person. Now, this
yeah,
third person, based only on the responses and not being able to see anything, has to guess which of them is a computer and which of them is a real person.
right. So again, to make this like work, the questions aren't really communicated by speaking or anything. It's either written or typed and then passed into the room. And the third person, the interrogator, like Saksham said, is to try and find out which person is a machine, which person is human, right? And obviously, in the
Mhm.
situation, if the human is trying to prove they're actually human, they can say things like, I'm human, the other person is a machine. But if the machine can think on its own,
Yeah.
right, it will successfully be able to fool the interrogator into thinking it's the human by saying things, by you can say similar things. The other person is actually the
Hmm.
machine, I'm the human, and maybe it can outthink the human, right? And basically, what
Hmm.
Turing said in the imitation game, which is later called the Turing test, is that if if you have a machine that can successfully imitate a human like this and fool another human into
Hmm.
believing it is human, that machine is deemed capable
Is
of thought,
yes,
and that
and that
machine
machine
can
can
think.
think.
Exactly.
Exactly. No, so I think that's a very interesting thing because till date, no AI has been able to beat the Turing test. It's not that I found on the internet at least. Uh, no AI program has been able to fool a human into thinking it's another human. And you can
Right.
think of
So
many instances where you've encountered such AIs that talk back to you, like a chatbot, for example, online, right? But you distinctly always know that that is an AI. That's not a
right.
real person talking back to you,
They're
and you're
very
able to tell
unnatural.
that.
It's very clearly something run by code, right? Something that's programmed to give you
Hmm.
specific answers repeatedly based on what you ask it, what you tell it, what information you give it. Sure, it does respond, and that's
Exactly.
great, I guess, but it doesn't successfully pass the Turing test. Maybe
Yeah,
someday
nothing has so
something
far.
will, and let's see. We'll discuss that
Yeah,
later
and
in the episode.
let's see. We're going to come to that. Yeah, I think the real
Right.
difference over here really comes to the computers are really black and white in the way that it's either this or this, binary again.
Yeah.
And because of that, real thinking is in black and white. You don't think most thoughts that you have in your head or most decisions you make aren't based on yes or no. There's always a scale, and you're always weighing things on a scale. And because of that, that's where AI comes in. Where AI has to weigh things on a scale, and it's not as simple as a black and white choice. Again, connecting this back to our last episode of quantum computers, I think that's why quantum computers are, at least we think of them, or I would predict that they're going to have a big revolution in AI because even quantum computers fundamentally don't work on black or white, or don't work on zeros and ones. They work on superposition and quantum entanglement, which is a more of an abstract
Exactly.
concept, which is more like quantum computer can be present in two states at the same time or any state in between the two states as well, right? So because of that, I think they're going to have a far bigger leap in AI than classical computers have been able to do so far.
Right.
Yeah.
If you want to learn more about the superposition of like quantum computers, you can go check it out. It's the episode we did right before this one. We've explained it pretty well there and pretty in depth,
Yeah,
actually.
and that really connects. You can really see how quantum computers would be better, fundamentally better than classical computers at AI. For a more technical definition, here it is. The ideal characteristic of artificial intelligence is a machine's ability to rationalize and take actions that have the best chance of of achieving a specific goal. And that's the definition of AI according to Investopedia. So yeah, do what you will with that. It's the ideal characteristic of artificial intelligence is the ability to rationalize and take actions that have the best chance of achieving a specific goal. So again, it's a scale-based thing. It's a probability-based thing. Best
Right.
chance of achieving whatever the goal is. Um, but yeah, you know what? Let's actually use this to get into exactly what AI is. Let's actually analyze this definition for a second, and let's get into what the world considers to be AI. Okay, because again,
Yeah.
something as abstract as intelligence is kind of hard to define. It really depends on each's own interpretation. Alan Turing says imitation. As long as a computer can imitate a human being, it's
Yeah.
intelligent.
It's not a
But
hard and fast
people
rule,
have
but
differing
you can't
views.
decide for everyone. So there's actually a few
Exactly, exactly.
definitions we can go by. So one is, I mean, if you look at AI, it's a branch, right? It's a branch of computer science related to
Mhm.
computer science things. So it's basically, if you think about it, it's a branch of computer science that tries to replicate human intelligence and human behaviors, but like in machines, right?
Yeah,
Because it's artificial
right.
intelligence, right? The intelligence part, intelligence is a human characteristic,
Mhm.
also animals, but here we're talking about the decisions that a human can make. We're trying to replicate
Yeah,
human intelligence and behaviors, but we don't want to replicate it maybe in animals or other humans. We want to replicate it in machines, in computers, right? And we're doing
Mhm.
it artificially, of course. Like they aren't born with that intelligence, so that's why you get this term, right?
Yeah,
Artificial. That's one definition of it. And in simple terms, artificial intelligence, like any form of artificial intelligence, is just a system that is able to perform tasks that you would usually require a human for.
yeah.
Basically,
Exactly.
you need artificial intelligence to behave like a human.
Hmm. Yeah. So again, you can already see there's there's a lot of gray area over here. You can interpret this in multiple different ways. You can uh define it in multiple different ways, and you can look at what you want to consider as intelligent, what you don't want to consider as intelligent. We want to cover four main ones over here, like the four big approaches that historically have been the most relevant in AI.
Right.
And you can really fit it into a neat table-like diagram over here, with two columns and two rows, where it's
Yeah.
humanly, rationally, and thinking and acting. Okay, what you
Right.
end up with is thinking humanly, thinking rationally, acting humanly, and acting rationally. Okay,
Right.
there's four total approaches that are the biggest ones in the field of AI. The thinking ones are related to reasoning and processing, and the acting ones are related to behavior. Okay, and we want
Yeah.
to go into these one by one in details. Yeah, let's start with thinking humanly.
Yeah. So we talk about thinking humanly, right? Like it's in the name. You want machines to think and process things like humans do, and that means when it comes to their thought process, that means when it comes to their reasoning, how they approach problems, right? So what it basically means is it's the cognitive modeling of the machines. You want these machines and these systems to start solving problems in a way that a human would do, as opposed to how humans have traditionally built machines, which to solve it in a
Mhm.
very black and white approach, right? Our machine would solve it. You don't want that anymore. You want them to now think
Yeah,
like
when
humans
when you think
and
of the
solve these
term,
problems how a human would.
when you think of the term a machine, you naturally come to the same conclusion. Slightly dumber than humans in a way. They can only do
Right.
certain tasks that humans are inherently smarter and can do a
Right.
more variety of tasks. Um, yeah, that's thinking humanly. Now that's thinking rationally, which is the use of logic. Here, you need to worry about stuff like modeling uncertainty and dealing with complexity. Okay, so what does that mean over here for a second? Basically, can a computer think 100% rationally all the time? We know humans can't for the most part,
Right.
but let's just say, a computer does. What's the challenges that come up with it? Challenges that come up with it is one, complexity. Okay, in a rational problem, what happens when you continue to introduce more and more and more and more and more complexity into it? Does the computer break? Because humans have a way that if we had to think about something completely rationally, no matter how much data you bring to it, it is physically possible for us to do it, right? Physically, you would eventually get through a very complex problem, right? You know how to break it down, categorize it, look at it
Right.
differently, etc., etc. For a computer, you would run on processing power eventually. If you give a super 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 complex problem, it just can't do it, right?
Right.
And the other thing was modeling uncertainty. So what happens when the problem you introduce to the computer has an uncertain factor in it? How does the computer then think about that rationally? Even
Right.
with uncertain situations, we are able to calculate, let's say, probability of something happening. Risk to reward
Right.
factor is often called. We're able to look at that in that perspective. How does the computer think rationally about those situations with uncertainty in them? So that's
Right.
what thinking rationally is about. Now we go to
Now,
acting.
yeah.
Yeah.
Yeah, we have the two acting approaches, which is acting humanly and acting rationally, right? So acting
Mhm.
humanly, again, just like with thinking humanly, it's in the name. You want them to behave like humans, and we've actually discussed this
Mhm.
before, like right before this, which is the Turing test, right? You need a computer to behave, not just solve problems like a human, because that's just the processing part, that's the thinking and the calculating and the reasoning part of it. You want it to actually behave outwards to other, maybe, I don't know, machines, any external factors. You want it to behave like a human. And again, here, that's where the Turing test is actually really effective, because if a machine can pass, can not only pass as a human, but make an actual human seem like a machine to another human,
Oh yeah.
that's a pretty good indicator that that machine
That's
can
that was
act as a human.
act humanly.
Yeah.
Exactly. Yeah. That's perfect.
Yeah.
Then we come to the last one, which is acting rationally. Okay. So this is about you know, how do you maximize what the performance that you're doing in the given circumstances? Okay. So based on whatever you know right now, how do you act in the most rational way possible? This differs from thinking rationally because over here, instead of just coming up with a situation, you actually have to do it as well. Okay, which is one of the biggest challenges with AI is to actually make it act in a rational way. Okay, acting generally is hard for AI, but rationally becomes even harder because of the fact that it has to actually eliminate a lot of different variables and approach the problem in that way. Okay, it has
Right.
to maximize performance in any given scenario based on the information it has available to it. So how does a computer automatically think and make its performance better in any scenario? For humans, for example, if we want to do, if we want to improve performance in something, we know how to do it, right? We know how to make tasks more efficient. We know how, if I have to print of a stamp, let's say 1,000 papers a day, there comes a point where I become so good at flipping papers and stamping it that I essentially improve my efficiency as opposed to when I wasn't. How does a computer do that automatically on its own?
Right.
That's why acting rationally comes in.
Yeah, and those are
So yeah,
basically the four approaches. There's thinking and acting, and in both in terms of humanly and rationally, right? Again, we can split it up
yeah.
by the table.
An additional thing that often gets covered into AI, which is not as big of a thing, but still I think is important enough to mention, is sensing. Which, like we said before, isn't considered AI anymore, and a lot of its variations that have taken place. But sensing still remains important because the AI can't think or act unless it can first take in the information, right? So
Right.
sensing is something like computer vision, let's say, speech recognition, like we talked about. Um, all of that also needs to be perfect in a perfect AI sense, if we get in a bit as
Right.
well,
One
for
example
it
is
to
actually like
think.
understanding languages. For example, like I'm sure this
Yeah.
happens to other people. You go on Google Translate and you want to translate something from one language to
Hmm.
another, but you type something that maybe isn't in either of those languages, but is in a third one. Instead of just
Hmm.
not being able to give you an output, right? What Google Translate does is it gives you a little pop-up. It says, "Did you mean?" And then the language in which
Exactly.
your input actually is
Exactly.
in, right? And that's a form of
Hmm.
AI sensing, right? That's the
Yeah.
Google Translate's artificial intelligence sensing that your
Hmm.
input is in a different language, and so it's doing that by
Yeah.
acting human. It's by acting like a human. Yeah.
Exactly. Yeah. So often we think of AIs because of science fiction and movies. We think of these humanoid robots that can talk and they can think, and them
Yeah.
taking over the world. But that's not strictly true. When we talk about intelligent beings or intelligent agents, let's call them, whether biological or non-biological, they both fall in the same category. So technically you could have an alien who's also intelligent, but if you can make an AI that's just as intelligent, they would both be considered on the same platform from an intelligence standpoint. So they can be point is they can be biological or they can also not be biological. Also,
Right.
they don't have to be a robot. They can also be a
Right.
program. For example, Google Translate is not a robot. It's simply a piece of code, a software, which is
Right.
just as intelligent as a human translator. Of course, not the entire, not the whole human translator, but for the translate function that the
Right.
human translator does, it's almost as intelligent.
Right. It's
So,
able to
uh,
provide that same service and that it's able to perform the same operations that the
yeah,
translating aspect of a human translator would do.
exactly, which is the main function of it. So on a
Right.
translating platform, at least, uh the human translator and Google Translate would more or less be considered the same. uh yeah, but again, this, so we have used Google Translate before. I know for a fact it's not perfect. Okay, a lot of times languages have certain terms that have a very specific connotation to that language, which they aren't able to understand. So even though we say, let's say Google Translate was perfect, in that scenario, yes, it'll be equal. But today, as we can see, it's not perfect. But why is
Right.
that? Right. So even in AI, you have different types of AI, right? And
Yeah.
there's two main types of AI, which is weak AI and strong AI,
Yeah.
which
They have
not very specific terms, not
yeah.
the best definition,
They're
but
pretty
it gets the
broad,
job
but
done
they
for
do
now.
manage
Yeah.
to like encompass every form
Hmm.
of AI out there. Right? So again, weak and
Yeah.
strong, and you can see just from the terms which one would be deemed better. Right. So that's how with
Hmm.
weak AI.
Strong AI.
Yeah. That's how with weak
Yeah.
AI. It's the AI that we use today as now. Every form of AI that we have as of like 2021 is weak AI, and it's the most successful type of AI today because we've actually managed to get it to work as
Get
a
it to
form of a
work.
weak AI. In
Yeah.
what working would be as a definition for weak AI, we've managed to achieve that, right? And it's also called narrow AI because we explained
Yeah.
that it isn't able to do as many things as you would want actual intelligent machine to do. And I'll tell you why. So weak AI focuses on a very limited context, right? For
Yeah.
example, Google Translate. it's able to replicate the
translates stuff.
translating aspect of a human translator's brain, but isn't able to do everything else that the human translator would do. Google Translate can't go and buy you food. It can't go and fill your car up with fuel. It can't do any of that. But what it can do is a very specific part of that human translator's operations, right? And that's why weak AI is also called narrow AI, right? It has a very narrow use, right? It can't do a
Scope
lot
of
of things.
operating.
Yeah, exactly.
It's
A
highly
very limited
specialized and it
context.
does that task well,
Yeah.
but that's it.
So when you're
There's no
creating
scope for broadening. That's you could broaden
Exactly.
that scope, but that would require you to step in and broaden it. The AI itself can't broaden the scope. For
Exactly.
example, Google Translate can't suddenly start correcting punctuation. You can build a punctuation character into it if you wanted to, but Translate
Right.
itself won't become that.
No, exactly. So when with weak AI, when it's created, you have a very limited context, but you need to make it as specialized and as like well working as possible in that context. So instead of focusing on instead of focusing on developing different areas of the intelligence, focus on one very specific portion, but make it really really good
Yeah.
to the point where it can basically replace a human's version of that operation, right?
Of
Like
that
Saksham was saying,
one specific operation.
yeah, like Saksham was saying, like if you had sure, Google Translate isn't perfect today, but if you had a perfect version of Google Translate where they're able to assess the connotations of different words, that would be a perfect replica of a human translator's ability, and that would be successful weak AI. Like it is fairly successful right now, but that would be 100%
That would be
successful
even more successful.
weak AI. Right, that would
Weak
be
AI.
100%
I think that's what the
successful weak
meme. That's what the meme or the joke of AI just being a bunch of if statements really becomes true at a certain level. Weak
Right.
AI is basically a bunch of if statements together. Okay, and it checks a bunch of different combinations and it arrives at the correct combination, and that's what it gives to you. Obviously, that's a very oversimplified image, but
Right.
you could build a weak AI with enough number of if statements if you were willing to code it that way. An example of it again: Google Translate, Siri, Alexa. Wait, yeah, Alexa, Google search, image recognition, self-driving
Self-driving
cars.
cars. Yeah. There actually is
Yeah,
one
you
really
got.
like important example we come across here, which is IBM's Watson. All right.
Okay.
And I think it's important because not because it's more successful than the others anyway. It's more because even though it is weak AI, it feels more like what we would imagine AI to be if we didn't know much about it, right? Because you can think about Instagram. If you want a YouTube algorithm, right, it's a very concealed version of artificial intelligence. Yeah, it's hunting, it's taking your information based on that, it's recommending things to you. But isn't very like apparent, right? You wouldn't look at it and go like, okay, that's AI. You'd learn how the YouTube algorithm works, and you'd be like, okay, fine, this is why it's behaving like a human. IBM's Watson
Yeah.
is a bit more to like humans in a way. It's actually a question and answer service, right? It's a data analytics processor. So basically, you give it data, it processes it, it gives you answers, and it's named after the founder of IBM, who is Thomas J. Watson. So what it does is, I told you, it's a question answer service. So it analyzes your human speech for like meaning and syntax, and based on that, it gives you answers. But just because
Oh,
it
okay.
gives you
Wow.
answers, right? Just because it gives you answers, which is a very human behavior. That's why it's a more aberrant version of AI than the others. It's very clear to see that it is behaving like a human, because something that will speak and give you answers when you ask it a question, that's a human behavior right there, and it's very like visual and clear. That's why
Yeah.
IBM's Watson
But
is a very important
despite all
example.
that, it's still considered weak AI.
Yeah, it is still definitely weak AI because it's that one thing they can do. It can answer your questions and nothing else.
Exactly.
Right.
And this brings us to the this brings us to video games actually. One of your Fried Circuit episodes are video games. Video games also have AI. Stealth video games.
Right.
But at that
We
point, AI
discussed
is
this in
a
our
joke. Like it's
quantum computers episode too.
yeah, we talked about this as well in the quantum computers episode. But yeah, video games also have AI if you consider that to be intelligent. But yes,
Right.
that you know what, those are some examples of very very weak AI, where
Yeah.
basically it is an if statement. If you are here, you're spotted. If you're not here, you're not spotted. That's it.
Right.
But yeah,
If
that is
I'm a
also called AI.
non-playable character, if I'm the god, if I'm the AI, and this is my field of vision, if Saksham as a player walks past this position in the game when I am at this
Yeah.
position, he's caught. Otherwise, he's fine.
Otherwise, he's
It's
not called. This is
very,
very black
very
and white.
simplistic.
Yeah.
Right.
But you know what? If all that is weak AI, then what's strong AI? So strong AI is a hypothetical concept. It's not real. We don't know. It doesn't exist yet. It's a theoretical concept that we have thought of, which would be the definition essentially of true intelligence, of like the ultimate form of intelligence. And this is much more than if statements. So you know
Right.
what? If you want to visualize this as if statements, this would be like a billion if statements. If you're willing to actually code a billion, trillion if statements, more than a billion if statements. Yeah, the most absurdly large number of if statements. If you could code that,
Right.
that would be
So
strong
you think an
AI.
if statement wasn't if statement. If statement is basically you checking for some condition
Mhm.
and making a decision based on that. It's a very human concept, right? Like, okay, if
Mhm.
my glass has water, I will take a sip. If it does not, I will pour water, then take a sip, right? I check for condition,
Mhm.
make a decision. Now imagine for strong AI, you want to behave as close to as what a human would be as possible, right? So you want to do everything a human can do. So you just
Yeah,
think about all the possible decisions you could ever make, all the possible situations you could ever evaluate, right? Everything you have to ever check for,
make a if
right?
statement for that, and that's
Yeah,
strong
make it
AI.
if even for each one, or like a
Mhm.
combination of two different conditions based on some action. And if you put all those if statements together, that is what a strong AI would look like. So it's very,
Yeah,
very like broad. It can cover basically everything.
exactly. Or imagine this. Or imagine a computer designing the if statements itself, and then
Right.
answering those if questions itself.
Right. It's like how you would
That's
learn as a child, right?
intelligence.
Like I would,
Yeah.
I'd stub my toe, and my brain would go, okay, don't put your toe near
Mhm.
hard objects, and then that's me learning and
Yeah,
inserting another if statement in
exactly.
my
It's
brain.
it's it's it's
That's how
Wade
strong
making
AI
the if
would work.
statement himself and then answering
Yeah.
the if statement itself. That's what AI is. That's what strong AI is, and that's true
Exactly.
intelligence. All right. So
Right.
a few things that you would so for example, a strong AI program would include everything you ever want. Okay. Look at Jarvis from Avengers, Tony Stark's AI. No matter what he asks Jarvis, Jarvis always has an answer
Right.
because Jarvis can look at the question, analyze it, create if statements for it, and then answer the if statements itself. So whether it's launching drone strikes, preparing new
Right.
suits, or even coffee, Jarvis can do all of that, can make all that happen because it's a
Jobs can
strong
basically
AI.
do whatever you'd want a human to do for you, right? So
Exactly.
if
That's what makes him the perfect
Tony
assistant.
Stark says,
Yeah.
Jarvis, get me a pizza,
Mhm.
the end result is because of Jarvis, you would have a pizza in front of you. Iron Man
You
would have
have
a pizza.
pizza.
Exactly.
Exactly. It'd be the
Anything
same as
that you would
telling
want a
your
human to do.
assistant to get you a pizza.
Exactly.
Yeah.
Anything that you want a human to do, Jarvis would be able to do. And that's why Jarvis
Exactly.
is fictional because
Uh,
strong
yeah.
AI
So
doesn't
a
do those
key
things. Yeah.
few characteristics of strong AI are the ability to reason, solve puzzles, make judgments, plan, learn, and communicate. It should also have consciousness, objective thought, self-awareness, sentience, and sapience,
Right.
which is the definition of strong AI according to again our friends over at Investopedia.
But if
Uh,
you think about all
yeah,
these are basically just human characteristics. You want to be able to think,
exactly.
you
It's
want to be able
everything
to
a human
reason,
mind can do.
you want it to be you want to be a sentient being, right? You want it to have
Mhm.
self-awareness. These are all very human characteristics, a lot of which you don't find in machines traditionally. You basically
Yeah,
want a machine, in very simple terms, you want a machine that can behave like a human, but very well, like exactly like a human. Can do everything a
exactly.
human
I
can
think
do, can think
we
like a
take stuff
human.
for granted. But the what's it? Many philosophers have said that the only so you heard the term that everything is not real. Nothing is real. It's all an illusion. Life in the world is an illusion. But every philosopher agrees on one concept, which is the concept of that I am. I am is absolute. Like you exist. And the fact that as humans we know that we exist and that existence is real and that I am or I exist is something we take for granted, something we don't think about every day, right? But that itself is a very, very important characteristic of intelligence. A computer
Right,
doesn't know about its existence. For example,
right,
my laptop doesn't know that it exists as a laptop and that it is a thing. It
right.
can't think of that for itself, but strong AI can. It's
You
essentially everything
probably
you see in a sci-fi movie.
heard the expression "I
Yeah,
think, therefore I am." Right?
yeah,
If
exactly.
you gave machines the ability to think like a human, actually think, actually be intelligent, just because it
Yeah.
can think and it is self-aware, one of the points that we listed right now,
Mhm.
it would know it exists, and like it would know it exists solely based on the fact that it can think, and that's why
Yeah,
intelligence is human, right?
exactly. And that's strong AI. We haven't got to that yet. Who knows?
Yeah.
We might. Some say it's never
We'll
gonna
see.
come, but yeah, we're gonna come to that in a
As
bit.
of now,
But
it's
yeah,
mainly a part of like science fiction, like we said, right? Jarvis
yeah, it's
or
just a theoretical concept.
right.
Hmm. But yeah, okay, fine. Now now that we covered that, let's talk about machine learning, the other biggest word. Okay, so I think
Yeah.
two
The
things you hear a
second
lot
big
with machine
buzzword.
learning. Second big buzzword, yes,
Yeah.
prevent you from getting scammed. So it's machine learning and deep learning, which are two different what's it? Applications? Yeah, you got the applications. They're two different
I would say there are two
applications or two
different
different,
forms of creating AI, or like
yeah, two
forms
different
forms in which AI functions.
implementations.
Yeah,
Yeah,
exactly.
two different implementations of artificial intelligence could be machine learning and deep learning.
Right.
uh, these are often used interchangeably when you're talking about AI, but there's a very big fundamental difference in
Yeah, they're
them
very, very
that's
different.
very important to be aware of, right? Like, but other people usually throw the words around randomly. So, machine learning, deep learning, same thing. But no, there's a big difference, and you need to know the differences. So, yeah, let's talk about machine learning firstly. Um, the way machine learning works is, again, it's an algorithm. Okay, so it takes data, like we said, analyzes it, and then acts on it. It's quite basic, in the sense that it's, again, like if statements technically. It requires humans to give data and also to establish its behavior. So it's basically weak AI. We give data to a machine. We say you do XYZ with data. No, we give them XYZ. We say
Yeah.
you do ABC on XYZ and give me
Yeah.
result, I don't know,
Yeah.
PQR.
It's basically
And
humans giving the machine very specific instructions for how to analyze and how to give output. For example, I write a program, right? And a program that calculates the sum of numbers. There, I write, okay, take one value as input from the human, take a
yeah.
second value as input from the human. If both values are numbers, add them and give us output. If they're not both
Hmm.
numbers, tell the human that you need to input numbers, right? There you're giving
Yeah,
it,
very simple program.
again, you're giving it the
Hmm.
data, you're giving it the ability to analyze the data, what exactly to do, and you're giving it the ability to give you output. That is a very, very, very
Yeah,
basic form of machine learning. Obviously, that's very basic,
machine
but
learning.
it still
Yeah,
qualifies, right? Yeah.
you get the point. Most AI today is machine learning. In fact, everything you see around you is probably machine learning. Okay, but now we come to deep learning. So the biggest thing over here is to understand that deep learning is machine learning, but better. It's the next form or the evolution almost of machine learning. It's taking machine learning and fixing all of the problems in it. So if machine learning is just algorithms of if statements, deep learning is layers of algorithms. Algorithms
Right.
stacked on top of each other to form something called a neural network, which is
Yeah.
similar to a brain. Like a brain is
So,
basically a neural network,
yeah. So it's
and
an
that's what deep
artificial
learning
neural network.
creates.
Yeah.
Exactly. So it's like it's basically what you want AI to be is deep learning. It's multiple
Yeah.
algorithms layered to form a picture of your brain or a model of your brain almost. The way this works is that it learns from its mistakes to fix its behavior automatically. So if your code was to give you a wrong output with machine learning, let's say an if statement wasn't added into it, or the statement was a wrong if statement, or it saw the data wrong. It can be in the sensing, thinking, and acting chain of events. If any of those things go wrong, a deep learning code or a deep learning piece of code or software would correct that mistake on its own and then give you the right answer.
Right. It would adapt to it. So, for example, again with the same
Hmm.
program, if I gave it two inputs, right, and I wanted to find the sum, it would it would look at the inputs. It would go, okay, I'm trained to give an output for two numbers. These aren't two numbers. So it would just tell the user that you can input two numbers, and then it would learn that, okay, every time I don't get two numbers, I do this, and every time I do get two numbers, I give an output. It would learn on its own, and
Yeah.
that's
So
deep learning.
basically, that if statement that Wade's previous program had, the check for numbers, if you remove that statement, it would just like simply take numbers and add them. And if this was a deep learning piece of code, it would add that if statement itself by understanding that it can't add like two letters together,
Right.
right? And that's where deep learning comes in. Basically, constructs, like we said, like in strong AI, its own if statements and then answers the if statements itself.
Right. Exactly.
Yeah.
I
So
mean,
instead of humans having to step in and design its functionality or design the way it operates and the way it gives outputs, the AI itself does that. And naturally, for something like deep learning, you require huge amounts of data. Like we're not talking about simple hard drives. We're talking about servers and servers and server racks of data added up all together. And that really is helped by the fact that we live in the age of big data. And because of that, because we have so much data generated on the internet every second, and so much of
right.
it happening, where that phenomenon will essentially push AI forward and push deep learning forward and take us into uh, bigger and better things with AI.
Right. And these are AI is actually used for a lot of things, because right now we're talking about how you need such
Mhm.
like extensive storage. You need so much stuff to actually fuel it. But sometimes we can't do that.
Yeah.
We are doing that, and we've actually gotten some pretty impressive results doing that, right?
Mhm.
Tons of applications of AI in the world we live in today. We give you a few. Right? We give you like Instagram, Snapchat, Twitter, social media networks, Google
Mhm.
Translate. But it goes
Yeah.
a lot
It's
further. It
also
goes a
it's
lot
also
further
more,
than just
I think a big
yeah,
field for AI is also medicine.
yeah,
So stuff like diagnosing diseases, for example.
right,
There's multiple practices that use AI and deep learning to identify patterns of, lung cancer or strokes or cardiac arrest. And they're able to run these simulations, and they're able to analyze properly, much better than a human, in fact, because they have so much data available to them that they're
right,
able to
yeah,
predict a stroke in a person much quicker, or
yeah. So
analyze
like
how likely you are to have a stroke.
again, like it's deep learning, right? They learn very,
Mhm.
very, very quickly. So they see a pattern, they say, okay, fine, this pattern has led to numerous strokes in the past. It'll learn that really
Mhm.
quickly. And then since it already has so much computational power, the next time it sees a pattern that seems similar to that, it'll immediately diagnose based on the data it has. You know, is a stroke, is not a stroke. And it has the power
Mhm.
to do that because it has all the information at hand ready. And it has the power to process that information, which is something humans don't have, right? Humans don't have all that information on hand, right? Doctors aren't going to always remember
Yeah.
everything. They might have looked through records, they might have Google things. Doctors aren't like perfect because in terms of memory, here all the memory is there physically on like hard drives,
Mhm.
disks, servers, right?
Yeah.
And who's the RAM, the processing power, all there. So here you're basically guaranteed a higher success rate than just humans, right? And it's getting more advanced by the day. You can use this for lung cancer, you
Yeah.
can use this for strokes, the risk of cardiac arrest. There are tons of different applications for
Mhm.
diagnosing diseases using machine learning,
Mhm.
using deep learning. Sorry,
It's also
yeah,
used to develop medicines and vaccines faster. It's able to identify target cells better, able to identify the diseases better because it has so much data to work on. It's
right,
able to You're able to also get personalized treatment. So based on who you are and your disease and your specific conditions, the AI program is able to make a specific treatment only for you that works specifically for you, which a doctor can't do as well as an AI can, because the AI has the data from like millions of people across the world, or billions even. It's able to
right,
tailor make specific treatments for your specific condition,
right. And
which then leads to
they
better
can do it a
treatment.
lot faster
Yeah.
than doctors because with doctors, right? Doctors have a set of symptoms to work with, and based on that, they usually
Hmm.
give you like a one cure fits all kind of approach, right? Where
Yeah,
okay,
yeah, yeah.
you show the symptoms, you take these pills these many times a day, and you're done. It's not very personalized. It's probably
Hmm.
advice the doctors given to like hundreds of people, thousands of people, whatever, right?
Hmm.
With deep learning, they identify the small differences in different patients. They see how those differences were approached in different patients, and with all that, based on the difference between you and the next patient, they'll be able to give you some very, very personalized treatment, something that will fit you perfectly, giving you a much better chance of maybe prevention if that's what you're looking for, or maybe a cure if that's what you're looking for, right? Or recovery. Basically, whatever it gives you a way more successful key to good health, and that's why it's very, very
Yeah.
important because everyone knows the medicinal field is extremely important,
Yeah.
right?
Another very cool use of AI is cars, self-driving cars. So, because a lot of accidents, like obviously, there's a bunch of accidents happen every year in the world, right? And most of these accidents are actually caused by human error. If you eliminate the human error, if everyone's in a self-driving car, that actually makes driving much safer. You're able to prevent a large quantity of accidents that happen every year. And that's another field where AI is working great in. Also, the fact that if everyone has AI, imagine what that would do for parking and efficiency.
Exactly. People struggling with
No
park
one's
now. Like
ever parked out
you
of
go on,
line.
you go on the road right now.
Yeah,
People are struggling to parallel park. People are struggling because
it's
there's
so
not
hard to
enough
park.
space to reverse properly, or like not enough space the front or back. There's enough space for your car, which doesn't leave you a lot of wiggle room for reversing.
Yeah.
Cars fix that. AI fixes that, right? Because you have computers who have algorithms, they have the information. They just need to analyze it again, analyze, give you the output, and slot it in perfectly. And if you talk about AI
And
with cars, right? You talk about artificial intelligence in cars is a lot more mainstream, at least in terms of like knowledge, people knowing about it. It's a lot more mainstream than the medicine aspect because everyone's heard about Tesla. Everyone talks about Elon Musk, Tesla all the time, and they're definitely the biggest example of self-driving
in the
vehicles.
self-driving car
And what's really
market,
cool
yeah.
is here it's very clearly like successful, right? Like, you can go and buy a Tesla. Tesla's it's a product that people buy all the time. It's a successful product. It works for sure, and it's not just experimental anymore, right? It's not something that's being developed and researched and will be available in the
It's very
future.
real, yeah.
It's very real.
I mean,
And
even
like I was
Teslas don't
watching a
have
video.
full self-driving. Like
Yeah,
they call it full self-driving, but it's still like has its little quirks in it.
yeah.
But
No,
yes, we're definitely
I was
going
watching a
towards a
video
future
today
where everyone can have
on
full
yeah, I was
self-driving.
watching a video
Yeah.
today on Instagram of someone sitting inside the Tesla while it is like self-driving. And on that
Mhm.
little display on the Tesla dashboard, right? It shows the car, shows the Tesla itself, and on the side, obviously, it shows the display of the road. It's able
Mhm.
to identify individual traffic cones on either side of the road, like down to
Oh
like
wow. Okay.
exactly how
Yeah.
many.
Yeah.
So I'm passing 10 right
Mhm.
now on the side and 10 right on the side. On my display, it's showing me the car, showing the road, and showing me 10 orange traffic cones placed exactly where they are in real life relative to the car. And
Yeah.
this it just shows
That's
you
really
how
great. You know,
developed
with
Tesla's technology is.
yeah, that's another sensing factor. You know, the fact that it can sense 20 cones at the same time. If
Exactly,
you're
exactly.
driving, like as a human being, you won't be able to clock all 20. You know, you might see a few of them, you might get a rough idea of what's happening, but the car
Right.
is able to see all 10 cones and analyze for all 10 cones, which again would make driving way, way safer with a
But
Tesla.
yeah, those are good aspects, right? Those are a couple of the good applications of AI,
Yeah.
right? Something that's really helping people around. But of course, like with most things in life, you have some good aspects, there are going to be some
Flip
bad
side.
ones.
Yeah. Now
And
we get
one
into the bad
example,
stuff.
yeah, one
Yeah.
example of a bad, like just morally bad application of artificial intelligence, actually deep
Hmm.
fakes, all right? And deep fakes could
Oh,
be used for good, right?
yeah.
Like they could be used for good, but generally they have this negative connotation attached to them because
I think
just about the
there's a whole consent factor to it, right? Like for
right.
example, in the Mandalorian, when they deepfaked Luke Skywalker, he consented to it. He was doing a
Wait,
performance
I
for a
think
movie or a
we
TV
should just
show.
explain what deepfakes are first,
Oh
like
yeah,
in case
oh
it.
yeah. Actually, yeah, we haven't gotten a deepfake. Yeah, exactly.
Yeah,
Fine.
so
You don't
deepfakes
know
are
what a deepfake
basically
is? Yeah,
yeah.
fine. You do it. You do it.
Okay,
Go ahead.
so deepfakes are basically imposing some image
Hmm.
or some footage onto another piece of existing footage in a way that seems extremely realistic. So, for example, if I record myself walking down a corridor, right?
Hmm.
If I have enough data, and when I say data, I mean like images, like individual frames, individual angles of Saksham's face, right, at different angles,
Hmm.
different positions, making different expressions. I can impose his face onto mine, but not in a way that looks very badly photoshopped. It's in a way where when I
It's
render the
super
final video,
realistic.
it's gonna look like Saksham
Hmm.
is walking down that exact corridor, exact like maybe hand gestures, maybe
Yeah,
walking pattern, all of that exactly the same as mine was,
exactly to the
just
T.
with his face,
Yeah,
and it looks extremely realistic. You're actually gonna believe, okay,
it'll be
that video
me.
was recorded with Saksham walking.
Yeah, and you know, it seems like a very cool piece of technology, and it is. It's
It's
incredibly
extremely
like
cool.
cool to look at,
It's just being used for a
but
lot of bad stuff.
uh, it can be used for a lot of bad stuff. And again, I was going to that consent part of it. So, for example, in a TV show like Mandalorian, where Luke Skywalker was deep faked, he consented to that. He was performing on set of a TV show. He wanted to look a certain way, look younger. That's fine. But what happens when someone takes another person's face and puts it on another piece of video that they didn't consent to, that was
Right.
never meant to be created? And what happens when people who watch that video aren't able to tell that it's edited?
Because again,
And this
it's
might seem
highly
like a very
realistic.
futuristic, very, very bad scenario, but it exists right now. You can do it right now if you had the tech and the data to pull it off.
What if I
And I
have
think that's so,
access
so
to
dangerous.
what if I have access to footage of someone committing a crime, right?
Yeah.
What if I also have access to, again, images, individual frames of
Hmm.
Saksham's face? Maybe I've taken them from a video, maybe
Yeah.
his pictures are available Wi-Fi, maybe I've gotten them personally, whatever it is. If I have access to something like someone committing a crime, and I have access to a lot of data regarding Saksham's face, who's to
Hmm.
stop me from just deep faking Saksham's face onto that
Yeah. That's a
video and make it look like Saksham's
no,
committing a
no,
crime?
no. Okay. Yeah. No, don't do that. But yes, exactly. That you can see where this could create multiple problems, where footages
Right.
or videos essentially of as evidence for anything becomes less and less reliable as deepfakes spread around the world. Imagine world leaders, imagine famous people getting deepfaked onto different things, and you can see how much chaos it would cause in the world with deepfakes. But that's not all. You also have autonomous weapons, which is something that a lot of governments are heavily investing in. autonomous weapons. Yes. Why have soldiers fight your war when you can have robots do it? Which is a great idea that I'm totally for. One second, why have war in the first place? But if you
Yeah,
were to have war, autonomous weapons sound like a great idea because they'll, limit the loss of human life.
right.
Sending out machines in the field to do it, they're much more
Exactly.
efficient, they're much better. But what happens when it goes wrong? War is not a very simple concept. War is very complicated. There's a lot of different moral
Right.
ambiguity associated with it. And as we
Yeah.
said before, AI is not good when it comes to moral ambiguity. We haven't
Yeah.
reached that level yet.
Machines
You
are good
know,
with black and white situations. You should do this or you shouldn't do
hmm
this. This makes
exactly.
sense.
See
This
person,
doesn't.
kill person. That's it.
Right. What happens
A
when
see
if you're
person in red outfit, kill person
intelligence,
red outfit.
but then a
What happens
civilian
if
dies
it's
in the
a good
process?
person in a red outfit?
Exactly. Exactly.
Right? Exactly. So I think
There's a
when
lot
it
of
comes
like
to moral
moral
choices in
choices
war,
associated.
who to kill, who not to kill, what context are
Right.
you in, etc.,
Right.
etc. Autonomous weapons can't do that.
Yeah.
They don't
Machines cannot
have the
make.
capability to get to that. We already have autonomous weapons that exist in society right now.
Right.
So it really has to, something has to be done about this, where either you improve the tech to a point where everyone can 100% agree this is exactly how we think. Because again, even in humans, moral ambiguity still exists. Like, everyone has a different set of morals, a different moral code they
Right.
follow. Everyone
Everyone has
believes in
different
different
like.
different things.
Yeah, everyone has
Yeah.
different ideologies, different opinions on things. That's why we have conflicts to
Hmm.
begin with. That's why we have governments being overthrown. That's why we have wars between
Hmm,
countries.
hmm,
That's
hmm.
why people being oppressed, right? It's all because of
Exactly.
these ideologies and these
So
differences. But what
who's gonna
happens,
give this the stamp
right?
that a piece of AI is now morally sound? You can't. It's not possible.
Right.
And
Right.
and
Because
giving
we're
something
basically
like weapons.
introducing all this moral
Hmm.
ambiguity that's already causing so many problems in humans into machines who are arguably much more powerful in the processing and actually acting
And they
stages.
have a
Maybe
much bigger impact
it,
also. Like we're talking about stuff
exactly
like weapons. Weapons can take a life, and you don't really
right.
want that decision to be morally ambiguous at any point.
Right. You
You
want to
want
be
it to be black and white. In
certain,
fact, you don't want to kill people
100%.
in the first place. But if you had
Right.
to, you don't want it to be like that. And then you also have the fact of accountability. So what happens if a mistake is made? Who's accountable? Do you blame the AI or do you blame the humans controlling it or humans who made it? At
Right.
what point does the AI's learning change it enough that it's its own entity at this point?
Right.
A lot of those things haven't been ironed out, and that's why we aren't ready for autonomous weapons right now. You know, um, what happens if someone hacks it? What happens if the AI suddenly decides that the war has become too morally wrong for them, and the AI flips on us? Like the weapons that we send out in the field of war decide that we're the bad guys, and they're in their moral compass or with their moral ideology, and they flip on
Right.
us. A lot of dangerous scenarios you can think of with this. A lot of ways can go
Really
wrong,
big
in
questions
my
in the
opinion, at
situation
least.
that you don't want
Exactly.
machines who are capable of controlling weapons to make.
Hmm.
Right. You barely
Exactly.
want
And I think
humans
this,
to make them. So then why would you want
hmm.
machines to?
This perfectly brings us into the future of AI. And people have been
Yeah.
saying about AI. We're not the only ones who are concerned. There's a whole bunch of people out there. But also, like, where do we see this going? Where do we see AI going? How far can we take it?
Right.
Will strong AI ever be a reality? Like, is it possible for us to reach that level of intelligence that we can artificially just create on our own?
Yeah.
Um, so yeah,
It's
a
actually the
couple of
question
theories on
about.
this.
Yeah, it's actually the
Hmm.
question of, can AI not only reach human level at some point, can it actually exceed human intelligence? Because then who's in control,
Yeah.
right? Then you actually have artificial intelligence,
Look at
and
me.
it's
I'm
actually a
the captain
possibility.
now.
Yeah, because we discussed this
Uh,
in our quantum computers
mhm.
episode, Moore's law, right? Which is it's not a
Yeah.
law; it's more of a historical law. It's observational law. It's more of a
It's
trend,
an observation law.
right?
Yeah, it's more of
Which
a
is
trend.
basically over the years, right? Since transistors started being used in computers, the number
Mhm.
of transistors in a circuit has doubled every 2 years, okay? Which is a huge number, right? You think about anything
Yeah.
exponential, it's huge. It gets really big really quickly.
Yeah.
Now, with those transistors, with an increase in the number of transistors, comes an increase in your intelligence. Because what is intelligence made of? Think of,
I know.
again, thinking
Computational
rationally and
capacity.
acting rationally, thinking humanly,
Yeah.
acting humanly. Right? That's all related to
Mhm.
processing and computing and acting. Right? All of that is
On
just
big amounts
boosted
of
by an
data.
increase in number of transistors. So as this
Yeah.
number continues to
So,
double every 2 years, how strong will it
mhm.
get? How powerful will intelligence get?
Just how
That's a
far will
question I'm
Moore's
thinking
law
about.
take us? When does it
Yeah.
fail? So the theory is that we'll reach a point of technological singularity. That's what they call it, according to Moore's law, which what that means is basically a point of no return, where technological progress reaches a point where AI is improving itself so quickly and at a much faster rate than human evolution that we can never catch up. There's never a chance for us to ever become as intelligent or as advanced as AI, and AI just takes off and goes exceeds human intelligence, but by a huge margin. And it's a very interesting person over here called Ray Kurzweil, who's himself a very interesting guy. You should definitely check him out and look him up.
Yeah.
Um, he's got
called a
many
futurist.
predictions right historically. Called a futurist, yeah. It's one of the things he
Futurist, which
does,
means he just makes
where he
predictions
predicts
about the future.
things,
And
and
he's
he's been very
literally
right
along.
about stuff.
Yeah.
Yeah, exactly. So he has predicted based on Moore's law that desktop computers, the same ones that we use every day, will have the same processing power as a human brain by 2029, and that the singularity will occur in 2045, which is not
Right.
that far away. Both those dates
Yeah.
are not that far away.
Honestly,
We're going to
think
be
about
around
it.
to see that happen.
8 years from now, your computer will be able to process
We'll be
the
as
same
smart as
amount of
you.
things that you can. As smart as your
Yeah.
computer will be as smart as you. And by 2045, they don't need you anymore. They've
Yeah,
completely
by 2045, the rate is so high that you can never catch up.
Right, exactly. At that point, humanity is just
That point, what happens? At that point, we have no idea what happens. So, because see,
right.
a very interesting, what's it called? Paradox over here. Not paradox, but almost a catch-22 situation over here. That if we were to reach that singularity, right? Even try to predict or even try to think what will happen beyond the singularity is beyond us, because singularity means that AI has far outpaced us, is far beyond us, so it's even beyond our comprehension to try to predict or try to envision what's going to happen then. It's literally out of our control, because at that point it depends on someone else who is far more intelligent than we are. So
Yeah.
we don't even know what's going to look like, but we have a bunch of theories again, as we do for everything, a bunch of possibilities. One of them is that humans were combined with machines to form cyborgs. We all have like an AI eye over here, or like an arm that's AI. The window, so that's not exactly AI, but yeah, we essentially have like AI implants in us and very cool things that essentially enable us. Like essentially, we like come together with the AI and the technological innovation that enable us to take the species to a different level almost, right? The other ones, basically every sci-fi movie, you have robots going around that have AI, and we have to pray to God that they have the same
They
morals
just
as us.
basically just break
They're on our
free and
side.
just surpass humans in every way possible. And at that point, you're basically at the robot's mercy.
Yeah, if they like you as pets, they'll keep you.
You
If they
have to
don't,
hope
we
that
all
they
die.
see life your way, they see the world around you the same way that humans do, so that they kind of cooperate, like let you cooperate with them. Actually,
Yeah, exactly. Alternatively, and this is the most interesting one so far, is that we might become AI. We've already talked about stuff like downloading our brains onto software, like uploading our brains to a
Right.
computer. What if we just transfer our consciousness into an AI? Like if we can build neural networks or deep learning or AI software that are as good as our brains, why not just live as a software? You can never die. You can have infinite power. You only grow and you improve on yourself again and again at a much faster rate. Some call it the natural step in evolution for us. It makes sense as AI. If we only exist software, like we create new software as offspring, we continuously improve ourselves, we evolve as the software improves, and we go from being a carbon based life form to an electronic life form, which makes sense
Right.
because carbon based life is very weak. There's so many things that can kill us around us. If we
Yeah.
become code, nothing can kill you. And this actually one of the few options that exist for interstellar travel. Again, we're not watching a space episode where interstellar travel is going to take thousands of years for us, which no carbon-based life, which like at least we know of, but maybe some can, but yeah, which we as a carbon-based life form can't survive for that long. But if we were able to upload our brains into a software, we could go on for millions of years. We could actually colonize entire galaxies as a species. So maybe AI isn't that bad. Maybe us becoming AI is the future.
Maybe
Who knows?
maybe it's a natural, like Sakram said, maybe it's a natural step in evolution because we have the technology. Maybe you just implement it to an extent that no one's really been able to do so far. Maybe that's where
and
AI takes us next.
we surpass our carbon life form.
Yeah. A lot of people are actually concerned about AI, and you might have seen this.
Rightfully so. Yeah. Even I am. I'm not sure about this.
Yeah, but like a
I
lot
don't
of
know.
a lot of famous, a lot of important people are concerned about AI, and you have people like the physicist Stephen Hawking. You have Microsoft founder Bill Gates. You have SpaceX. Elon Musk himself,
Elon
the
Musk
man
again.
behind
We cannot go a single episode
every
without
episode,
mentioning
every
Elon
episode.
Musk.
Yeah, the man behind self-driving cars and that whole
Yeah,
application of AI is also very concerned about AI. Right? He realized that yes,
yeah,
it can be useful with limits. Right? You keep it within the limits, yeah, it can be very useful. If you just
yeah.
let it
Nobody
run
is nobody is
unbounded,
saying just abandon AI and just let it be and then
right?
just let the concept rot away. What these people are saying is that we need to enforce strict regulation regarding AI. We need to make sure that the AI that we do create is the most positive AI and actually improves our life instead of going
Yeah,
far beyond our control. We don't want to create something. We don't want to open Pandora's box essentially. Because after that,
right.
there's no control on it. If we reach a singularity, which people say that we will, beyond that, it's out of our hands. So we want to make sure that everything we do make never takes us to that singularity, right?
Exactly.
And that's why a lot of prominent people who are behind um, projects that aim to control that aim to not control in a way, but aim to regulate that in a sense. Try to aim to steer it in the right direction towards constructive growth. So you'll see stuff like Peter Thiel, Amazon Web Services, and Musk. They've all committed $1 billion to this company is called OpenAI, which is a
Yeah.
non-profit company that is championing responsible AI development. To make
Right.
sure
They're
that we
overseeing AI development,
make
but
the
in a
right kind
way
of
that
AI.
will never come back and really overthrow humans or do any of the things we just talked about, right? Surpass
Yeah.
humans to an extent where they don't need us anymore. They're completely free. They might not, see eye to eye with us on moral issues, any of
Mhm.
that. They basically want to oversee AI development in a way that it's safe to use, has limitations, will be helpful to us, but won't get
Yeah,
to a
but
point where
never
it's
like
just
goes
completely
beyond
out of hand.
us.
Right.
Exactly. But again, then, as with any issue, there are people who are on the complete opposite end of the spectrum, who say AI will never reach that level. Like, it's not possible for us to create strong AI. It's not possible for us to create AI that reaches singularity and goes beyond us. A prominent person on that camp would be Mark Zuckerberg, the Zuck.
Right.
He is very optimistic about AI. He said, and he
Yeah.
said that Elon Musk's doomsday concerns are
Yeah.
quite far fetched, and that they are not possible and will never come.
Elon Musk
I don't know. It
and
remains to be
Mark
seen.
No, Elon
Mhm.
Musk and Mark Zuckerberg often talk about this publicly and often mention each other a lot, right? Where
Yeah, about
Musk
AI.
keeps talking about
Mhm.
his views and how he thinks AI is gonna go completely out of hand if it just remains unchecked.
Mhm.
And then Zuckerberg just responds and mentions him and talks about how his claims are totally unfounded. He doesn't have anything to be worried about. AI is just going to be
Yeah.
helpful and never actually surpass us, right? And who knows? Like as of now, we don't have enough information. AI hasn't really been
No.
developed enough for us to know, right? With like concrete evidence that either will surpass us and won't. How dangerous it actually is. We can't actually answer those questions yet. We can just have our
Mhm.
own opinions based on how
Yeah, I
far AI
mean,
has come.
time will show. Is Mark Zuckerberg right or is Elon Musk right?
Yeah.
What
And
do you
speaking
think,
of
Vivek? What do you think? Are
opinions,
you concerned about AI? Which camp
not
are
yet,
you in?
not yet.
Not
No,
yet, really? You're
no,
with the
no, so
Zuck?
no. I'm like okay, sure. I feel like maybe several years in the future, maybe it can get to a point where it's completely out of control. But I feel like just the way it's
Mhm.
going right now, for at least for the foreseeable future, it's just going to be useful. I don't think we're going to have. Sure, there are the moral dilemmas. There's
Same.
the
Mhm.
deep fakes and all that. I'm talking about in terms of AI overthrowing us. I don't think that's going to happen anytime soon.
No, but that's the thing, right? Is it gonna happen? Because Mark Zuckerberg says no, Elon Musk says yes, it will, and we need to stop that from happening.
What do
I
you
think
think?
I'm very concerned. AI freaks me out. No, I mean I get it, and I love AI and weak AI, and it's perfect. Does a lot of jobs very easy. I love my YouTube recommendations, but I don't want to go beyond that. I don't think we want to develop something that's going to be out of our control. And it's definitely a possibility. I think so, at least. I would definitely say that AI
Yeah,
development has to be done in the most responsible way possible to make sure that it doesn't go beyond our reach. You know, humans don't have the best track record with preventing this sort of stuff,
yeah,
and it's because we're so blinded by evolution or blinded by progressing and going to the next step. We don't think about whether we actually want to go there, or is it the best way to reach there.
yeah.
If you
No,
want to
I
have
get it.
some very specific tasks done very well, there is a way to maybe make weak AI reach that point instead of developing a strong AI that can do everything equally well. Maybe
Yeah.
I don't know, could be, but I'm definitely concerned about AI. I would definitely say that there needs to be some sort of regulation that to come into place.
Yeah.
Otherwise we're gonna be in trouble.
Yeah.
Anyway, yeah, that brings
That's
us
all.
to the end of the
And
podcast.
that's all we
What do
have
you
for
guys
today.
think? Are you optimistic on AI? Do you think it's gonna clear us all? Let us know in the
Leave a
comments.
comment. Tell us about
Leave a comment.
audio
We
being created
reply
by AI.
to almost all comments. We don't get any
Every
comments.
comment. Every comment.
We only
Right.
got like 1 or 2 comments. So yeah, if you put a comment in there, we'll definitely reply to your comment and
Yeah,
engage with
100%.
you.
And also, don't
In
forget
intellectual conversation.
Friday, 6th August, 4 p.m. Indian Standard
4
Time.
p.m. on the
It's a
special
live
Fried
episode
Circuit
with
episode.
special guest, right? You don't want to miss
Yeah.
that. Make sure you subscribe, hit the bell icons, you hit the notifications, and yeah, just
We'll
make sure
become YouTubers.
because the whole point of
Like,
special
share,
episodes is that
subscribe, comment. Listen to the audio version on Anchor if you don't like
right,
our faces
If you're
on YouTube.
Spotify or wherever and listen to the audio
On
version,
Spotify, bunch of places.
right, so,
Yep.
yeah.
Yep. Perfect.
Anyway, well,
See you
keep
guys
watching,
next time.
and yeah, bye.
Yep. Peace.